Welcome back. Today we're going to be talking about congruence. Once again, this is day number 2. Our content objective is students will be able to determine if two figures are congruent based on the definition of congruence. Language objective is students will be able to describe the properties of congruent figures and follow from the properties of rigid motion. And why am I learning this? Well, it's important for real world problems like creating video games. So let's go ahead and jump straight into the very first example. It says, answer the following. For part A, it says, in this case, there are several different transformations that will carry one figure onto the other. Describe one transformation that will carry A, B, C, D onto A prime, B prime, C prime, D prime. Well, right away, I'm noticing it seems as though it is a rotation. In fact, it looks like a 180-degree rotation. So I'm going to go ahead and say that it's a rotation about the origin 180 degrees. You'll notice I don't specify clockwise or counterclockwise, mainly because 180 degrees clockwise is exactly the same as 180 degrees counterclockwise. Please note that this is not the same for a 90-degree clockwise. It's not the same as a 90-degree counterclockwise. It only works for 180 degrees. So that's why we tend to not make it mandatory to write which direction it's going. Okay, so now for part B, it says, can you think of a different transformation or sequence of transformation that will carry A, B, C, D onto A prime, B prime, C prime, D prime? The answer is yes. To me, it kind of looks like there's also a multiple of reflections. So let me show you. Here, starting with A, B, C, D, I'd like you to notice that first what's happening is you can think of it as, hey, it's being reflected off of the y-axis here so that we can land this quadrilateral onto this side. Now, in order to get this shape but onto A prime, B prime, C prime, D prime, I'm going to have to reflect it once more, but this time across the y-axis so that it can land right on itself. So basically what I saw was a reflection off the y-axis and then a reflection off of the x-axis. So I went ahead and put that. Now, technically, there is another option. Okay, it's not a huge difference, but you could have also thought of it as, hey, it's being reflected off of the x-axis first, like that, and then it's going to be reflected off of the y-axis here, and once again, it would land exactly on A prime, B prime, C prime, D prime. So either or is going to work, and hopefully you've recognized from the previous lessons that every single time it's a 180-degree rotation about the origin, you might recognize that a double reflection, one off of the x-axis, one off the y-axis, is equivalent to that. So the next question is, write a congruent statement for the transformation above. So basically, these are quadrilaterals since they're four-sided, and A corresponds to A prime, B corresponds to B prime, C corresponds to C prime, D corresponds to D prime, and for that reason, I can go ahead and basically use this format, but go ahead and write quad in front. So I'm going to put quadrilateral A, B, C, D is congruent to quadrilateral A prime, B prime, C prime, D prime. Moving on to number 2. It says the two figures below are congruent. A, describe the transformation or sequence of transformations that will carry triangle LMN onto triangle EDF. So first of all, I have to look and assess the image and see how could I possibly get triangle LMN onto EDF. Right away, my brain is thinking, okay, it's probably a reflection because it looks like a flipped version of the other. So I'm going to go ahead and look for the line of reflection, see if it's possible. Now, a good way to find the line of reflection is to basically find the midpoint of corresponding points. So if you look here, I like to pick 2 points that are closest together. I can go ahead and say that M corresponds to D. So I'm going to go ahead and connect these 2 points together. And what I would like to do now is find the middle point, the midpoint. So what is the point that's right in between? So it's 1, 2, 3, 4, 5, 6, 7, 8 units apart. So the middle would be right here. So 4 units apart on each side. So I'm going to go ahead and say that the line is right in between there. So let me clean that up for you. That is going to be my line of reflection. Okay, and for that reason, let's see, what's the equation going to be? A good way to test it out is to pick 2 points. So I'm going to go ahead and say that this here is negative 2 comma 7, and this point here is negative 2 comma 4. You'll notice that both negative 2's are in the x coordinate, so I'm going to go ahead and say that the equation is x equals negative 2. So to answer the question, well, what transformation did I see to carry triangle LMN onto EDF? I would say that essentially it's a reflection across the line x equals negative 2. Next question, part B. Congruent figures have corresponding parts. They're matching sides and angles. For example, in the figure above, segment LM corresponds to segment ED, and angle D corresponds to angle M. List the other corresponding parts below. So here, what I like to do is I like to identify the location of each and every one of the variables here. So I'm going to go ahead and say this is the first, second, third, first, second, third. This makes it very easy for me to map out which variable corresponds to the other. So here you can quickly see D, which is in the second location, also corresponds to M, which is in the second location as well. It makes it very easy and very simple for me. So here it's asking me segment LN corresponds to what? Well, LN, that's going to be the first and the third. So I'm going to go ahead and say that that corresponds to segment EF. Okay, so I'm going to go ahead and write that. Make sure you write the bar on top to identify the fact that it is a line segment. Next one, segment MN corresponds to, well, let's see, MN is the second and the third. So I'm going to say that corresponds to DF. Okay, now real quick, what I want you to also understand is, yes, you can definitely use the statement to help guide you to get to the answer. It's a nice, easy way of doing it, but some of you may feel a little bit more comfortable looking at a visual here. So here you might be able to say, okay, LN here corresponds to EF. You can visually see that those side links are congruent. However, I do highly suggest you practice using the congruent statement because it's very efficient and very accurate as long as the statement is true. Okay, so moving on here, angle E corresponds to what? Well, angle E is in the first position, so I'm going to go ahead and say it corresponds to angle L. So I'm going to go ahead and write it like that. Now here, again, you can quickly visualize here, angle E is congruent to angle L. But I will say this, there are times when the figure can be a little bit misleading, especially if it's rotated. It could be a little bit unsure of which angle is really congruent to what. So that's when you, again, want to use your congruent statement instead. So last but not least, angle F corresponds to, here it's the third letter. So I'm going to go ahead and say it corresponds to angle N. So real quick, I'm just going to annotate that just so that you can see angle F, use 2 tick marks now, is congruent to angle N, like so. Okay, so now moving on to number 3. It says the shapes below are congruent. So with that said, I'd like you to go ahead and pause the video and give number 3 your best shot. Okay, so let's see how well we did. First, let's quickly read over the instructions. What are they asking us to do? A, it says to list the congruent corresponding parts. B, write a congruent statement for the triangles. And C, annotate the diagram to show which parts are congruent. So first, I would like to say this. I think the best thing to do is to first create a congruent statement. Why? Because if I have a congruent statement, it's going to make it very easy for me to go ahead and list all the congruent angles and to list all the corresponding line segments that are congruent. So for that reason, I will be doing this out of order. I'm going to go jump to part B first to write that congruent statement. So first, in order to make the congruent statement, just like in the previous lesson, I told you I like to first go ahead and label the different side lengths so I can see what length is the shortest and the longest, etc. So here I start with the shortest side. This is the shortest. This one's the shortest. This is the second shortest, and this is the longest side. So I'm going to go ahead and do that. Now the reason why I did this is it makes it easier for me to figure out what corresponds to what. So let's first start with a triangle. I'm going to go ahead and say triangle, let's say XYZ. XYZ is congruent to triangle what? Well, first let's trace out what's happening here. So starting with X and going to Y, we're going to 3 tick marks and then 1 tick mark. And that's enough information for me to follow through with. So notice on this side, what I'm trying to do is to mimic the same path. I need to travel along 3 tick marks, which is the longest side, and then get to the shortest length. And the only way to do that is by starting on P, okay? Starting on P, notice I'm traveling across the longest side, which is the 3 tick marks, and then traveling across the shortest side, which is the 1 tick mark. And for that reason, I'm able to determine that starting with P, the congruent statement will be completed with triangle PRQ. Now, please remember there are multiple ways of writing congruent statement because the order of the letters in this case doesn't matter. I could have started with Y or Z as long as the corresponding points here are listed in the correct order to match up, then it's totally fine. But using this one, I can go ahead and list my congruent corresponding parts. Now, what I like to do is go ahead and identify the different locations of each point. So I'm going to call this the first, second, third. Same here, first, second, third. I want to apologize. I know my handwriting is super sloppy, so bear with me here. So the first thing we're going to do is label all the congruent angles. So here I'm going to say angle X is congruent to, well, angle X corresponds to angle P, which is both in the first position, so I'm going to say angle P. Next one, angle Y, let's write that in, angle Y is congruent to, well, it's the second one here, so I'm going to say the second one is R, is congruent to angle R. Next one, angle Z, which is in the third spot, I guess you can say it, angle Z, is congruent to angle Q, which is also the last letter. So now that I have all the congruent angles, I'm going to go ahead and move on to congruent line segments. So what I like to do is just kind of go in order 1, 2. So I'm going to say line segment XY is congruent to angle, sorry, not angle, line segment PR. Moving on to 2, 3, I'm going to say line segment YZ is congruent to 2, 3. 2, 3 here would be RQ. And then last but not least, because there's still one more, we should expect 3 sides, is you are going to use the first and the last letter. So I'm going to go ahead and say line segment XZ is congruent to line segment PQ. Okay, so at that point, I'm expected to annotate the diagram to show which parts are congruent. Probably would have been a great idea to do it as I was creating this, but I completely forgot. So let's go ahead and use what we see here to annotate what we have. We already annotated the line segments, which is great. Let's just go ahead and add in the congruent angle. So X corresponds to P, so 1 tick mark, 1 tick mark. Y corresponds to R, so I'm going to just put 2 tick marks, Y and R. And last but not least, angle Z corresponds to Q, so now I have to put 3 tick marks and Q. And there you have your annotated figure. And that's all there is to it. So hopefully you were able to get the same answers as me. Again, this might be not exactly the same, but it's very similar to it. But all of these corresponding line segments and angles should be exactly the same. Now moving on to the next problem. Number 4, it says use triangle ABC as a pre-image each time. X comma Y gives you X comma Y plus 5. Is the resulting image congruent to triangle ABC? Why or why not? So first, let me teach you how you would use this coordinate rule to create your new image. So first, it's going to be definitely beneficial for you to list all of the ordered pairs out. I'm going to go ahead and say that A is -6, 3. B is, let's see, -3, 4. Then last but not least, C is -2, 1. Now that I have these ordered pairs, I can go ahead and transform them to new ordered pairs based on this coordinate rule. So looking at A, first of all, we first have -6, -3. It's asking us to take X, which is -6, and then to take Y, which is -3, and add 5 to it. So now I'm going to end up with A prime as -6, well, -3 plus 5 is 2. So that's going to be my new point. I'm going to repeat this process with B. B is -3, 4. They want me to take X, which is -3, take Y, which is 4, and then go ahead and add 5 to that. So here I'm going to say that B prime is -3, 9. And then C, using -2, 1, I'm going to go ahead and take X, which is a -2, and then take Y, which is 1, and of course add 5 once more, which is going to give me C prime is -2, 6. So now that I have these ordered pairs, you can go ahead and graph it, which is going to basically mean that it's translated 5 up. Okay, so to answer the question, is the resulting image congruent to triangle ABC? Taking a look at it visually, I can definitely see that they are congruent. But why? Because technically what happened was it was a translation. Translation is a rigid motion, and we know that a rigid motion preserves congruency. So I'm going to go ahead and say that yes, this rule results in a translation, and since translations are rigid motion, I know that the objects are congruent. And why? Once again, rigid motion preserves congruency. Moving on to the next one. So now here, let me backtrack here because it would be nice to already have the ordered pairs. Now we're going to go ahead and use this coordinate rule. So it says X, Y is going to turn into -X, Y. Is the resulting image congruent to triangle ABC? Why or why not? So let's go ahead and repeat this process using A, which is -6, 3. I'm going to go ahead and take the opposite of X, so that's going to give me 6, and keep Y the same, so that's going to be 3. So this is A. Whoops, forgot to put that in, A prime. Now let's try B. B is -3, 4. So B prime is going to become, well, the opposite of X, which is a +3, and we're going to keep Y the same, so we're going to keep that a 4. And last but not least, for C, we have -2, 1 is going to become, well, let's see, the opposite of X, which is a +2, and keeping Y the same, that's going to become a 1. So you'll notice once I plot these points in, you're going to find that it is essentially a reflection. Okay, here was my C prime, this was my B prime, and this is my A prime. So to answer the question, are these shapes congruent? Just by looking at it, we can definitely see that they are congruent, but how else can we defend that it is congruent? Well, we can say that it's a reflection, and we know that since a reflection is a rigid motion, I know for sure that the two objects are congruent because rigid motion definitely preserves congruencies. So let's write that in. Okay, so now moving on to number 5. It says here, use triangle ABC as a pre-image each time. For part C, we want to use X, Y, which gives you X, 2Y, and the resulting image is the resulting image congruent to triangle ABC. Why or why not? So real quick, because I want to keep the ordered pairs there, and we take off everything else. Let's go ahead and use the coordinate rule and see what we end up with. So starting with A, which is -6, 3, I need to keep x the same, so that's negative 6, but I'm going to double y, so 2 times y. So 2 times 3 is 6. So this is my a prime. I keep forgetting to do that. Okay, so for point B, which is negative 3 comma 4. B prime is going to be, well, x is going to stay the same, so we're going to keep it as negative 3, but the y is going to be doubled because we multiply by 2, so 4 doubled becomes an 8. And last but not least, for C, we have negative 2 comma 1. So here C prime is going to be x is the same, but y gets doubled. So these are my new ordered pairs. Now watch, I will go ahead and show you what it's going to look like once I plot it. Negative 6 comma 6, negative 2 comma 2, and negative 3 comma 8. You're going to end up with that shape. Is the resulting image congruent to triangle ABC? Why or why not? Well, take a look. Does it look congruent to you? The answer is no. And I could go ahead and say that it's not, because it's not a rigid motion. It wasn't a translation, it wasn't a reflection, and it definitely wasn't a rotation. And for that reason, the object that's created is not congruent. Now on to the next question. It says, x comma y will give you 2x comma 2y. Is a resulting image congruent to triangle ABC? Why or why not? Well, let's check it out and see. So the very first thing that I'm going to do is go ahead and figure out what a prime is. So starting with a, which is negative 6 comma 3, that will become a prime. I'm going to double x, so doubling negative 6 gives me negative 12. Doubling y, so that's going to give me 6. Repeat the process for b. b is negative 3 comma 4, which is going to give me b prime, which is doubling the x, which is negative 6, doubling the y, which is 8. And then last but not least, for c, we have negative 2 comma 1. So c prime is going to be the double of x, which is negative 4, the doubling of y, which is 2. So once we plot that, you're going to find that the shape is going to end up looking like that. Is the resulting image congruent to triangle ABC? Why or why not? I'm going to say no. It definitely looks larger. It does look like the same exact shape, but again, it is a larger size, so it's definitely not congruent. And how do I know this? Well, because that transformation was not a rigid motion. Again, it wasn't a reflection, it wasn't a rotation or a translation. For those reasons, I'm going to go ahead and say that no, it's not a rigid motion, and for those reasons, it's not congruent because the object is being stretched both vertically and horizontally, and it's basically double the size of the original image, which makes sense because we did double the x and we did double the y. Okay, just some future knowledge. These are both referred to as dilations. A dilation is a transformation that stretches or shrinks the original figure. Dilations do not represent rigid motion. Therefore, they do not preserve congruency. Let's go ahead and answer some more questions. For number 6, it says, which of the following properties of a figure can change during rigid motion? Explain. What about interior angles? Will those ever change? The answer is no, because under rigid motion, the shapes are going to be congruent, and with congruent shapes, all corresponding angles will always be the same. Okay, what about part B? Parallel lines in the pre-image. Once again, with rigid motion, the shapes will remain congruent, which means whatever was parallel in the very beginning, even after, once we do the transformation, it's going to remain parallel. So again, it's not going to change. C, the orientation. I'm going to definitely say yes, it can change. Okay, with rotations, obviously it's the orientation has been moved, and with reflections it's being flipped over a line. So we're going to say yes, it's possible for the orientation to change. What about side lengths? I'm going to say no. Why? Because again, with rigid motion, the figures are going to be congruent to one another, and for that reason, all corresponding sides are going to be congruent. The side lengths will not change. So we're going to say no, it's not going to change. What about the location in the plane? I'm going to say yes, it happens all the time with rigid motion. It happens with translations, reflections, and rotations. What about the perimeter? Again, it goes back to the shapes are congruent, and because they are congruent, same shape, same size, the perimeter is also going to be preserved. So no, it's not going to change. What about area? Again, with rigid motion, you're going to have congruent shapes. When you have the same size and the same shape, you're obviously going to preserve the area. So I'm going to say no, it's not going to change under rigid motion. Well, that is going to actually conclude the lesson for today. Thank you so much for tuning in. And as always, until next time, bye.